So welcome to part 3 of resultant force, equilibrium of a rigid body and equilibrant. I will stop at when two forces are acting on a body at an angle theta to each other, where we've been able to establish that the resultant force F is equals to F1 square plus F2 square plus 2F1 F2 cos theta. Cos theta. This is the formula of finding resultant. When you have two forces acting at an angle theta to each other, this is the formula for finding the resultant. Remember the direction of the resultant, alpha, we say is tan inverse of F1 sine theta all over F2 plus F1 cos theta. We have done something like this. So this is the formula. Now, what of if the angle now, if theta is obtuse, that is 90 degrees less than theta, theta less 180 degrees. Look at the diagram. You have two forces acting on a body at an angle. This theta now is greater than 90 but less than 180. How do you find the resultant? The resultant is equals to, just say F1 square plus F2 square minus 2F1 F2 cos theta. For actually, this one is true for 0 degree less than theta, theta less than 90 degree. Why this formula is true for 90 degree less than theta, theta less 180 degrees. That's how to get the resultant. So we want to look at example. Example 1. Two forces of magnitude, let me say this is 2 Newton and this is 3 Newton. They are acting on a body at an angle 30 degrees to each other. Then you have to find the resultant. Here. The formula is F is equals to F1 square plus F2 square plus 2F1 F2 cos theta. Then square root. So F9 is equals to, what is F1? Call this one to be F1. Can call this one to be F2. So you can say this is 2 square plus 3 square plus 2 times 3, then cos 60 degrees, then square roots. Then you continue. F is equals to square root of 4 plus 9 plus 12 into cos 60 is 0.5. F now will now be square root of, this one will give you 13. 12 multiplied 0.5 will give you 6. So let's complete it here. Our F now will now be square root of 19. Square root of 19 Newton. That's the resultant force. So that is, let me say, that's how to find the resultant. B, let's say you have to find the direction of the resultant. Direction of the resultant force. The direction of the resultant force. How do you find the direction of the resultant force? That is alpha. So we have established that alpha is equals to tan inverse of F1 sine theta, everything over F2 plus F1 cos theta. That is alpha. So if you continue, alpha will now be tan inverse of F1 sine theta. What is F1? F1 is equals to 2. It will be 2 sine 60 degrees all over F2. That is 3 plus 2 cos 60 degrees. is equals to tan inverse of 2 times sine 60 degrees 0.8660 divided by f2, that is 3 plus 2 cos 0.5. 0.5. Cos 60 degrees is 0.5. Alpha now will now be tan inverse of 1.732. Everything out over 3 plus 1. This is what you have. Alpha will now be tan inverse of 1.732 divided by 4. This is what you have. Alpha now is equals to tan inverse of 0.433 when you divide it. So alpha now will now be tan inverse of this will give you 23.41 degrees. So that is the direction of the resultant. This is the direction of the, in case you have to find direction of the resultant. Then let's see part of the question now. They say, what is the effect? This is jump question. What is the effect of increasing the angle from 60 degrees to 120 degrees? What is the effect of increasing the angle from 60 degrees to 120 degrees? What's the effect? So, remember this angle greater than 90 but less than 180. So, what is the effect of increasing the angle from 90 degrees on the result? Sorry, on the resultant. On the resultant force. On the resultant force. So, F is equals to F1 square plus F2 square minus 2F1 F2 cos theta. You know this is the formula when the angle is obtuse, when you are given an obtuse angle. So F now will now be equals to 2 square plus 3 square minus 2 times 3, then cos 60, cos 120 now, sorry, cos 120 degrees, square root. F9 is equals to square root of 4 plus 9 minus 12, then cos 120. You remember it will be negative in the second quadrant. So when you take away 180 from this, it will be minus cos 60 degrees. Minus cos 60 degrees. Minus cos 60 degrees. F now will now be equals to square root of 13 minus 12 plus 12 into 0.5. So our F will now be equals to square root of 13 plus 6 as well. So our final answer here will now be F is equals to root 6 plus that's root 19 Newton. You can see when the angle was 60 degrees, resultant was square root of 19 Newton. Now that the angle has been increased from 60 degrees to 120 degrees, resultant still remain the same. So the answer will now be it has no effect, meaning it has no effect. That is, the resultant force is constant. The resultant force is constant, meaning remain the same. The resultant force remain the same. Let's see another example. We call it example 2. You have two forces acting on a body at an angle 150 degrees to each 150 degrees to each other 150 degrees. This is 3 Newton. This is 4 Newton. Then calculate the resultant force. Calculate the resultant force. Calculate the resultant force. Calculate the resultant force. Then you use F is equals to F1 square plus F2 square plus minus 2F1 F2 cos theta square root. So F9 is equals to F1. I can say 3 square. Let's call this one F1, this one to be F2. plus 4 squared minus 2 times 3 times 4, then cos 150 degrees, square root. F now will now be square root of 9 plus 16 minus, this will be 12, 24. 24 into cos 150. You take away 150 from 180. That is 30 degrees. And cosine in second quadrant is negative. So this one will be minus cos 30 degrees. Or you use your calculator. See the same thing. F9 is equals to square root of, this one will be 25 plus 24 into cos 30 degree. Cos 30 degree will give you 0.6660. That's the answer. That's the resultant force. Under vector representation, take note of this. Vector representation. Vector representation under vector polygon. So under vector representation, remember, if you have, always take note of this. You have, let me say you have R here, you have P here, you have another vector, you have Q here. Vector PQ is what you have. From here, you will discover that this is the resultant. The line of actions of R and P meet at a point here. So Q is the one moving in opposite direction, as you can see it. So Q is the resultant. You say Q is equal to vector Q is equals to vector R plus vector P. So Q is equals to P plus R, where Q is the vector, is the resultant vector. That is Q is equals to summation of the two. Please take note of that. This is diagram 1. 2. Let's say you have something like this, something like this, something like this, something like this. You have this to be A, vector A. You have this to be vector B. You have this to be vector C. You have to be vector D. So from here, this and this, they have their line of actions meeting at a point. So you have vector A plus vector B, the same. You had this one in opposite is equals to vector C plus another vector D. This is how you are going to add vectorially. This is the addition of a vector, vectorially. Addition of vectors. We are dealing with addition of vectors here. This is how you are going to do. This is a vector, this is a vector. And representation of vector, please take note of this again. Let's say you have a vector here. You have this to be a vector, let me call it vector R. It has vertical components at an angle theta to the horizontal. It has vertical components here. We call it opposite over hypotenuse. This is R sin theta. While this one is R cos theta. This is R sin theta, this is R cos theta. Please take note of that. The vertical component, this is RY, this is R horizontal component. So vectorially, let me call this, I can say R is equals to, let's represent this to be R1, let me call it R1. R1 to be equals to R cos theta or R sin theta. Let's call it R sin theta. And R2, let's call it R cos theta. R cos theta. So for the vertical, call it J component. For the horizontal, call it I component. So this one can be written as R is equals to, the vertical component is this, while the horizontal component is this. So I can say I R cos theta plus J R sin theta. J R sin theta. This one represents horizontal component, while this J represents vertical vertical component. You can have it like that. So let me call it, anywhere you see R1, call it R sin theta. Anywhere we see R2, call it R cos theta. So R now vector R is equals to R cos theta is R1. Let me say I R1 or R1I plus R2 R sin theta, call it R2J. R2J. So it can be written like this. It can be written like this. So let's see example here. Always remember to find magnitude of R. Magnitude of R is equals to R1 square plus R2 square root. This is exactly what we are going to find, where R is equals to magnitude of vector R. So we want to see example 1. Let's see example 1. We are given a vector P to be 3i plus 4j. Let's say in Newton. Okay, in Newton, let's say P is a vector, it's a force. So find, let me use F. Now say find the magnitude. Find the magnitude of F. Find the magnitude of F. Definitely, if you still remember, F is equals to F1 square plus F2 square root. That's what we are going to use here to find the magnitude. So F9 is equals to F1 is 3. You say 3 square plus 4 square root. F9 is equals to 9 plus 16 square root. F9 is equals to square root of 25. F9 is equals to 5 Newton. This is the magnitude of the force given in that manner. So let's see example 2. Example 2. This aspect shall be treated when we get to a topic, vector, in further mathematics. But here, just get the idea. So example 2. You have something like this. They call it P. 2i plus 3j. They call it Q. Vector Q. Vector Q. They call it 3i minus 2j. And you have vector R is unknown. And that's a find vector R. You have to find vector R. Like I've said, you can see this one the same direction, meaning this is the resultant. You can see that R is equals to, will be summation of P and Q, is equals to P, vector P plus vector Q. We are going to hatch. So this one will be R is equals to, what is P? 2i plus 3j plus vector Q, 3i minus 2j. Once you add all these three together, vector R will now be, this is 5i, 3j minus that is plus j is the value. In case you have to find the magnitude of vector R, you know what you are going to do? To find magnitude of vector R, definitely you are going to square this to be 5 squared plus 1 square root. So the answer will be square root of 25 plus 1. Then the answer will be square root of, square root of 21 plus, that is square root of 26. Then units. That will be the answer. You have to find the magnitude of R. Please always take the direction, very important. You can see this and this the same. Why this one is opposite? I know that this is the resultant. You are going to add this and this to get this. That is example 2.